So again, where we are, this is week 7, approximating with a distribution. That's chapter 5. That's what we're starting today. And to do that, we're going to look at hypothesis tests and review what it means to be a distribution and the different kinds of distributions. The hypothesis test we're going to do right now is about Hermiston home prices. So I have several friends that have either moved to Pendleton or moved away from Pendleton or are buying a new house in Pendleton or in Hermiston. And one thing that's been noted is prices seem to be higher. Okay, they seem to be higher. And you know, we can look at that and say, oh yeah, this seems a little bit higher than last year. So I collected some data and I'm wondering, are house prices significantly higher? Are house prices significantly higher? And one big goal last week was to figure out what the heck does significantly mean. I'm going to answer that today. So to answer this question, I need a bunch of information. So I've got a spreadsheet here, data I collected. I'm going to share it out to y'all if you want to play along with me. Otherwise, feel free to. So again, when we share through Google, we want to make sure the link we give people, anyone can view it, unless we share specifically with their email address. Sharing with a whole bunch of people, this is the easy way to go. All right, so in the chat, you should find a link to my Google Doc if you want to get the data. And load this up a touch. Okay. So I went out earlier this year. I think this was in February, is my recollection. Pretty sure it was February. And I collected a bunch of home prices on different days in Zillow about Hermiston homes for sale. It's kind of random because houses come and go on the market and you never know what's going to happen. You get some low price houses, you get some high price houses, you get some houses in the middle. This is a kind of a random sample. I have 31 that the computer counted for me, and I'm using the count command on that column to say, hey, how many numbers are in that column? And then average command, things we did way back in week 1 and week 2 of the course. And then I asked for the standard deviation of this sample. So here are my 3 sample statistics that I need in order to perform a hypothesis test. Another thing I need is a hypothesis. I don't exactly have one yet. I have a question. It's not really a hypothesis. So a hypothesis needs a question or a claim, and then it needs some past knowledge, some prior information called the null hypothesis. So I'm going to go with my 2019 data. So I collected data back in 2019 in Hermiston, and there I found the mean house price was about $300,000. And sometimes when we're talking about house prices, we use a median instead of a mean as the measure of the center to deal with outliers. So if we think about that for a minute, let's look at my Hermiston data, see what it looks like. Yeah, look at the histogram. Ooh, that is wicked skewed right by $1 million house here. Whoa, look at that box plot. There's a big $800,000 house, $700,000 house, and $1 million house. Okay, so now I'm wondering, should I be using the median instead of the mean? So if I were to switch to the median, then I would have to run a hypothesis test on medians. We haven't talked about that, but it kind of works the same way, and Stackkey can do that, but I'm just going to stick with a mean comparison. Now, in talking about house prices, I think in general, it's better to use the median than the mean if there's any outliers in the data that we're looking at. And here, there are definitely some outliers. And I use the standard deviation rule to say, ooh, yeah, there's outliers. And I use the IQR rule to look for outliers. So there definitely are. And I'm going to violate standard practice. I'm not going to use the median here, even though that's the safe bet. I'm going to just compare means. So if you're comparing median to mean isn't really legit for a hypothesis test. So keeping it simple, I'm going to compare means. And my prior knowledge is that housing prices were around $300,000 on average in Hermiston. So house prices were about 300,000 in Hermiston. And then I have this question based on talking to people and looking at housing prices that they seem to be a little bit higher than that right now. And so are they measurably higher, or is it just a little higher but close enough to 300,000? So my hypotheses here, null hypothesis has to have an equal to. Now this just says higher. Higher is a greater than. There's no equal to there. So that would have to be my alternative hypothesis. A, a little better A, there we go. So my alternative is going to be a greater than, but first, let's see, what symbol do I need here? Is this a proportion or a mean? Let's see, I was looking at averages, that's a mean. For mean, we use the letter mu, right? So definitely got to know whether we're doing a mean or a proportion. My alternative was my question, and that was higher than the null, and I'm taking the null based on the prior data I had, which the mean was about 300,000. I'm just going to call it 300. So note here, what does mu mean? Mu is our mean in thousands and home prices. If we don't define our variables clearly, then when we try to interpret them later, we're not going to have anything significant to say, or it's just not going to make sense. So mu is our mean in thousands for home prices. Right. So then down here, I'll put the 300. So these are my hypotheses right there. Next thing I need to think about is what's my significance level? How important is this? Well, I mean, if house prices are up, they're up. What can I do about it? It's not life or death. If I really want a house, I got to pay a little more than I would have last year or the year before. So I'm just going to do the standard significance level, 5%. So significance, go, level, that's our alpha. And I'm just saying, hey, let's use 5%. Decimal version. So I got that. Next thing we need to do is take a look at the data and think about a sampling distribution. So back to the data over here, Hermiston. I have my sample mean, my sample standard deviation. Now I don't know the population standard deviation. I just have this estimate from the sample. And like the mean of a sample estimates the population mean, the standard deviation of a sample estimates the population standard deviation. We'll talk more about that next week. Next thing I really need to do is take this data and put it in Stackkey. So copy it, Stackkey, and the Stackkey, or your browser doesn't remember it. Oh, I just lost my copy. Stackkey link. Copy. All right, so let's see, what are we doing here? We are doing a hypothesis test. So I'm in this column over here, and then I have to decide, am I doing a single mean, a single proportions, difference in means, different in proportion, slope, correlation. And again, we're doing a mean, so I would like this one right here. So I gotta pick the right page in Stackkey, the right application. And here, Stackkey doesn't know about my housing prices, so I have to edit the data whenever I bring in foreign data. Stackkey doesn't know about. Highlight, delete existing, paste it in, double check we have the right buttons. So let's see, I do have a data has a header row up there, but I don't have a column in front of this saying which house is which. So it's okay that that's not checked. This is checked, that's good, okay. Stackkey then looks at my data and says, hey, this data has 31 items, and I already knew that in my spreadsheet, right? I have the spreadsheet calculate that. Stackkey says this has a mean of 333.332. I had 2 decimal places on mine. And Stackkey says the standard deviation is 111.675, which should match the standard deviation I got here, but I got 2 decimal places. And Stackkey, so one limitation of Stackkey that I haven't talked about that's going to come up next week is that Stackkey only gives me so many decimal places for anything I do. If I ever need more decimal places than that, then I have to go to a spreadsheet. So I'm going to also be starting to show some spreadsheet ways to do the things we were doing in Stackkey when we need more accuracy. And sometimes we do need more accuracy. Okay, let's see. I got my data. What else do I need to do in Stackkey to do a hypothesis test? I need to set the right null hypothesis. What's my null hypothesis? That the mean is 300,000. So change that. 300. Okay, all right. So sample data, null hypothesis. I'm ready to start generating thousands of samples. And we went over this procedure a bunch of times last week. So let's see, 7,000 samples. So what did I just do here? Well, my sample size is 31. I just ran 7,000 new samples, all of size 31, and had Stackkey record their means. So every time I move my cursor around here, it touches a new sample. The sample data is displayed over here. So I have 7,000 samples here, and I've plotted, or Stackkey plotted, the mean of each sample. The actual data set is listed to the right. All of those were resampled from this deck of cards right here. So a sampling distribution is when you have lots and lots of sample means in this case, and you graph the means. So this is a sampling distribution. It's different than the actual sample, and it's different than the population. So if we had all Hermiston houses and what they're, so we could easily get the assessed value from the city hall in Hermiston, but that's different than the market value of the house. Those don't necessarily match. And that's a whole nother problem. But let's suppose we had all prices of Hermiston homes, every single house in Hermiston, and we made a distribution of that. It would look different than this sample, and it would look different than this one right here. So anytime we're dealing with a population and a sample, there's kind of three things going on. There's the population that lives in the background, there's whatever sample we happen to have, and then there's the idea of a sampling distribution. The sampling distribution shape depends on a couple of things: the sample, the population, and the sample size. Tried to look at that sample size last week and the week before, and we'll keep looking at it in the next couple of weeks. So here's my sampling distribution. All right, so what next? Let's draw a little sketch to show where we're at. So this is my sketch for a sampling distribution. Hermiston home prices. And for the application, I didn't ask you to draw it. Well, I said you could draw it, but you could just copy and paste the Stackkey picture. I usually do both. So Hermiston home prices, thousands. And we have means from samples, size, n equals 31. And so far, all I really know about my distribution is it's got this kind of symmetric bell shape. And right in the middle there should be my 300,000, my mu from the population, from the null hypothesis, right? So that's from the null hypothesis there. Now, how far is it spread out? Got to go look at Stackkey for that. And because I want to know where my 333,000 sample mean lies. So in order to answer the question, is are the home prices significantly higher after we generate thousands of samples based on the sample and the right null hypothesis here, then we choose which test we want. My alternative hypothesis was greater than, which means I want a right tail test. And then the next thing I need to do is move my Zoom screen out of the way and enter my sample data down at the bottom here. So Stackkey just randomly, not randomly, but it says, hey, let's put 2.5% in the right tail. That's kind of its standard action. But I need to replace this mean housing price here with my mean. My mean according to Stackkey is 333,000.332. And once I do that, then I get my p-value. So my p-value based on, again, I got to enter my sample statistic, 333,000. And then this number up here is my p-value. So what does that mean here? It means of these 7,000 average home prices, 4.9% of them had means that were higher than my sample. So that's what a p-value is in this case. I'm getting a p-value of 4.9% out here in the right tail. So let's throw that in our sketch. So somewhere out, must be about here-ish, I have my X bar, 333,000.332 according to Stackkey. And then the number of other samples that ended up in this region, that's the p-value, was equal to about 4.9%. Now let's think about my significance level. So I picked a significance level alpha of 5%. And if I just double check with Stackkey on that 5%, so 4.9 is definitely less than 5. So that means that 5% region is going to be right about here is going to be the cutoff for that. And then it's that way. So this would be my alpha, it's 5%. And I'm just going to get that cutoff value here for average housing prices at the 5% significance level. So to do that, I just go back here and change the percent. That's where the significance level goes. That's a decimal 0.05. So Stackkey says, okay, so if you're looking for a significance level of 5%, the cutoff for that is an average housing price of about 332.932. Anything after that would be significantly higher than 300,000. So if we went out and collected another sample of 31 houses and we found that the average of those 31 houses was higher than 332.9 thousand, then that is significantly higher than 300,000. If we went and grabbed another sample of 31 houses and found the average housing price was only 320,000, we would conclude that's close enough to 300,000 to say the housing prices really haven't changed much, is what we're trying to say here. So that's that cutoff there. $332, I'm just going to go 0.9 thousand. And my mean's definitely greater than that. My p-value is less than the significance level. 0.049 is what Stackkey had told me. That's less than that 5% significance level. And anytime we have a p-value that's smaller than the significance level, we decide to reject the null hypothesis. This is what's called our decision, reject the null. Now that doesn't mean much to anybody else, so next we have to come up with a conclusion about what that means. We need to state what the p-value means, and we think about what does it mean to make an error in this case. So a little reminder of errors. All right, so reject the null means my data supports the alternative. So that's part of my conclusion. So rejecting null implies that the data, the sample, supports the alternative. What was the alternative? The alternative was that the mean was greater than 300,000. So next I just kind of state that in plain language. So something like, just for conclusion, have sufficient evidence that the average home price in Hermiston Oregon, in case some people aren't familiar with that, is more than, greater than, however you want to phrase that, 300,000. So that is our conclusion right there. Sometimes in like a write-up in a scientific paper, we might say what our p-value is, but here I'm just writing just a kind of a conclusion that I might, you know, end up in a newspaper article that I want to share with realtors in the area. Could we be wrong? Answer is yeah, we could have made a mistake about this. Our p-value actually is pretty darn close to 5%, but it's still less. So I'm in the region where I can say, hey, let's reject the null hypothesis. My mean is definitely higher than that cutoff when I asked Stackkey about the upper 5%. So that's the conclusion. Now, when we reject the null, but the null in reality is really true, which we don't really ever know that, that's called a type 1 error. So just a reminder about what it means to be a type 1 error. So type 1 error with hypothesis tests is rejecting the null when in reality the null hypothesis is true. And because I am rejecting the null hypothesis, it is possible that I'm making that type 1 error. The probability of making a type 1 error is that alpha. There's a 5% chance that I just made that error because alpha is what I'm used to make the cutoff, to say what's significant and what's not. So what does that mean? Okay, so I'm telling people that housing prices are higher. Significantly higher. Significantly. This year. When in reality, they're actually not. They're about the same. I don't know the reality. Never do, actually. In reality, housing prices aren't higher. So that's the situation if I'm making a type 1 error. Not higher. What's the consequence of that? Well, let's see. My friend's looking for a house. I say, hey, housing prices are a lot higher, significantly higher than they used to be. And he might say, oh, maybe I should wait and see what happens next year and decide to keep renting this year. Reality is housing prices aren't higher, so he could get a house about the same price that he could have last year or the year before, and he doesn't go to get a house. Who knows what's going to happen next year? Maybe they're going to be higher, maybe they're not. That's a risk. We have no idea about that. And so the consequence of this is I tell them housing prices are higher and they decide not to get a house. Or I tell them how housing prices are higher and they just believe it and they just go for it, you know? Okay, so I don't know what's the consequence. Who knows what's going to happen? Consequence. Maybe people wait to buy a house. Or they try to sell their house for too high a price. Oh yeah, that's a good one too, right? I do have a friend that's trying to sell their house and they said no one has bid on it. It's a like $500,000 house, which is above the average. So, you know, that could be part of the problem. They're asking too high a price in a market that's really not higher. That's an excellent point too. Thank you for pointing that out. So maybe, people decide not to buy now based on my saying, hey, housing prices are higher, watch out. People decide not to buy now. Or Tammy mentioned another consequence, someone who's selling puts too high of a price on their house. Seller puts too high a price because they think prices are higher, they're going to elevate their price, making house hard to sell. So this is kind of a brainstorming thing. So with the application, you kind of got to brainstorm. What are the consequences if you made this kind of error? So seller puts too high a price, making house hard to sell. All right, so it could have gone the other way though. So if somebody said, no, let's set the significance level to 1%, then that means my data isn't significantly higher, and I would choose to not reject the null. And I don't have to accept the null, but my data is closer to the null than not. So that would be a possibility of making a type 2 error. So let's think about that for a sec. So type 2 error is where we fail to reject the null. When in reality, the null hypothesis is false. Okay, so what's the situation here? If I were to fail to reject the null, then I would be saying housing prices don't seem to be significantly higher. Housing prices are not significantly higher. That's what I tell people, but they really are. My data was just weird. So this is what it would mean to fail to reject. I say housing prices aren't higher. I failed to say they were. But in reality, the null is false. That means they actually were higher. So, but they really are higher. All right, so what are the consequences that might happen here? So I go out and tell people that I want to buy, people that want to sell, realtors, hey, I did some research, and it turns out housing prices aren't much higher than they were last year in 2019. So what are they going to do? Well, they're going to look for houses. And maybe they're going to buy. And the house is probably a little higher than it was, significantly higher than it was 2 years ago. So look for houses, buy a house. That is significantly more expensive. Okay, could be the seller's perspective instead. So you know, another option here for consequence is seller doesn't put their house higher in price. So seller sells low when maybe they could have sold higher because the prices really were higher. So seller says low when housing prices are really higher. And could have made more money. And then I like to think about, well, which is worse, the type 1 error or the type 2 error here? So let's see, the type 2 error, somebody goes out looking for a house, they're told housing prices aren't higher, and they buy a house that's more expensive than it was last year or the year before. Yeah, that costs in the long run. That's kind of a big deal. Seller puts their house too low on the market, but it's probably going to sell quick, but they don't make as much money as they could have. On the other side, the type 1 error, which is where we're really at right now based on this data, is that maybe they decide not to buy, or they just realize, yeah, housing prices are higher. I'm just going to have to pay more because I need a house now. There's not much we can do about that. Seller puts too high of a price on a house, making it hard to sell. So then their houses are on the market for months and months and months because they're sure housing prices are higher and they're going to get more money, darn it. And then that can lead to all kinds of problems, right? Because sometimes it's hard to move and get a new house if you haven't sold your other house. Boy, I don't know which one's worse here. For seller, type 1 error is worse. For the buyer, type 2. Yeah, that's a good point. It depends on one's perspective. Absolutely. Seller type, yeah, that's where I'm leaning to. Yeah, for the buyer, for the type 1 error, still housing prices are higher. You could wait a little longer and hope, or you just buy a higher price house now because you need a house now. And then the other way, again, every situation is tough to think about. You got to kind of brainstorm to figure out what the consequences are. Yeah, they're looking for a house. They buy a significantly more expensive house when they thought the houses weren't more expensive. No, it is what it is. Seller sells low. They'll probably sell it quicker. Yeah, so I think for the seller, for sure, the type 1 error seems like the worst one. For the buyer, kind of sucks either way. All right, let's see. What else haven't we done here? We haven't actually interpreted. Oh no, we did interpret the p-value, didn't we? Or did we just state the conclusion? Let's go back. We have, we stated the conclusion or decision. We haven't interpreted the p-value, so we should do that next. Kind of skip that. What does the p-value mean? Interpret p-value. So remember, how did we get our p-value? So this is kind of where we got it, determines how we interpret it. So we took this sample data and our null hypothesis. We used the sample data to generate new samples of size 31 that were averaging around 300,000. And so reset, generate. So notice these centers are centered around 300,000, which is our null hypothesis. So we're assuming that houses really are around $300,000. And then we're using kind of the spread of this data right here to make these new samples, is what Stackkey is doing. We're wondering if this 333,000 is definitely higher than 300,000, but is it a lot higher? Well, that depends, and the sampling distribution helps us figure that out. So right tail, because that was my question, and because the sample data is higher, and then we plug in our 333, 2, hit OK here. Oh, look at this time, I got a p-value of 0.05. So I would have to, based on this sampling distribution, I would fail to reject on this one and possibly make a type 2 error. Interesting. So what is that p-value again? Okay, so assuming the null hypothesis is true, that represents the proportion of other samples like this one that have a higher mean than mine. So I just need to state that. Basically, how did I get this? I assumed it was 300,000. I looked to see how many other samples had a higher mean than mine. That percentage is the p-value right there. So probability notation, p-value is the probability of finding a sample mean that is greater than mine, 333,000 roughly, if I was expecting the mean to be about 300,000. Just to put that in words. And I'm gonna, based on the last two, I'm just gonna say it's about 5%, right? Which is that awkward position to be in. Oh, it's right on the cutoff, darn it. What do we do? So, let's see. Would you ever do multiple tests and then average the p-values, specifically when you have a p-value that is so close? Yeah, you could do that. It's going to be similar to just, instead of doing 6,000 samples at a time, to maybe doing 30,000 samples. It's going to be around the same result as that, and they're all going to hover around the same place, whatever that place is. And there is a theoretical marker to find that place we'll talk about next week. But yeah, sometimes I do that, and if it comes out jumping around that 5% all the time, then I just say, hey, it's around 5%. We could go either way here. But we usually lean on the side of caution and say, I don't think it's that significant, is what I would do here. So after doing 2 of these, I would kind of lean toward failing to reject instead of rejecting. And say, housing prices don't seem that much higher. They're just a little bit higher, not a lot higher. All right, so this p-value, what does that 5% right there mean? That's what it means to interpret. So the chance of finding another sample with a mean higher than 333,000 when we expected the mean to be about 300,000 is about 5%. So I'm just interpreting 5% of other samples will be greater than 333,000 if we were expecting the mean to be 300,000. So I just got to get that in a sentence somehow. And sentences usually look something like this for that. So that's the interpretation of the p-value. All right, I think we went over all the different kinds of questions here. Let's just double check before we move on to the next example. Thinking about that application that most of you did and a few of you are still working on. I didn't specifically, was I clear about what the population here is? Population is Hermiston home prices. The parameter is the mean, so that's over here. This is what we call the parameter. We think in the population of all Hermiston home prices, the average is about 300,000. Right, that's the parameter. Then we have a sample that we were working with that I listed on the next page. N equals 31 home prices, and the statistic. So the sample, N equals 31 home prices. That's the sample. I just want to be clear about all these things. And the statistic was that 333.33 average home price that we got. So I'm just kind of looking over what I asked you to write about. And these kind of population of the parameter, sample statistic, what are the hypotheses, p-value, what's the p-value mean, what's your decision, what's your conclusion, sketch either by hand or the Stackkey sketch, the Stackkey picture. Is this significant, right? Yeah, no, in this case I'm leaning toward, no, it's not really significant. What is a type 1 error? What is a type 2 error in this context, and which is worse? Okay, so we went over all that stuff there. So I hope this helps. So if you already submitted the application, but this gave you some ideas about how to make your submission better, resubmit, put a new one there. I'll see that you submitted more than once. I'll look at the newer one first, and then if I need to, I'll look back at any previous submissions. So feel free to resubmit if this was inspiring anyway or helpful, helped clarify anything for you. Otherwise, we're going to do another example.